Okay, question number 13 on our test 3 review for Math 1105 basically involves starting with a rectangular piece of paper or cardboard. In this case, I think I've given the dimension to be 10 centimeters by 20, cutting squares out of the corner and looking at the area of the bottom of the box. So let's kind of look at a picture. Alright, come with me to the paper. Here we go. Alright, so here's what we've got. I have an original rectangle that's 10 centimeters by 20. Obviously, this is not drawn to scale. I'm going to cut squares out of each corner. The squares I'm going to call x centimeters by x, okay? So x represents the length of a side of the square I'm cutting out, and it's measured in centimeters, because everything in this problem is centimeters. What happens when I do that? The problem tells me the bottom of the box has an area of 90 square centimeters. Now the bottom of the box is a rectangle, and of course you recall the formula. The area of a rectangle, length times width, will give you the area. Now, the bottom of the box, just the bottom part of the box, because the sides are folded up, this dimension right here on the bottom of the box is not 20 anymore. It's 20 minus x, because we took away x twice. So the length of the bottom of the box, algebraically, would be 20 minus 2x. And likewise, the width, the original width of the piece of paper was 10 centimeters. But when I just look at the bottom of the box, I started with 10, but I took away x twice. So the width of the bottom of the box would be 10 minus 2x. And I know that the length of the bottom of the box times the width of the bottom of the box gives me the area of the bottom of the box, which is 90 square centimeters. So there's our equation. Let's distribute. We get 20 times 10 is 200. 20 times the opposite of 2x is the opposite of 40x. Opposite of 2x times 10 is the opposite of 20x. Opposite of 2x times the opposite of 2x is a positive 4x squared, and this is equal to 90. I'm going to put the left-hand side in a better order. I'm going to write it as 4x squared. I'm going to collect the terms and get a negative, or rather the opposite of 60x. And then we have plus 200, and this is equal to 90. Now, I'm going to take this quadratic equation and put it in standard form by subtracting 90 from both sides, which will give me 4x squared minus 60x plus 110, and this is equal to 0. Now, a trick that I teach my students, even before you go to the quadratic formula, even before you try to factor, if you notice that every term in an equation is divisible by the same constant, I think it's a good idea to do it. And I notice here that every term is divisible by 2. So I'm going to divide by 2. Of course, I do this uniformly throughout the whole equation. You can only do this, by the way, when this is an equation, not an expression. And you end up getting 2x squared minus 30x plus 55 is equal to 0. Now, you might try to factor this, but I think you'll find out that it does not factor. So what we're going to need to do is go to the quadratic formula. A is going to be 2, B is going to be a negative 30, and C is going to be 55. Okay? So I'm going to go to my next sheet of paper to finish this. x is equal to, here we go, the opposite of b, negative 30, plus or minus the square root of b squared, that's negative 30, quantity squared, minus 4a is 2, and c is 55. And this is all over 2 times a. Okay, definitely calculator time. Some big numbers here. X is equal to, we got our bar, we have a 4, we have a 30, plus or minus the square root of negative 30 squared, of course, is 900. Negative 4 times 2 is negative 8. Negative 8 times 55 is a negative 440. So we have x is equal to 30 plus or minus the square root of 460 all over 4. Now, let's work with that, okay? Let's kind of go off to the side here for a minute. The square root of 460 can be broken apart as the square root of 4 times the square root of 115. That becomes 2 times the square root of 115. One of the best ways to figure that out is to just go ahead and use your calculator to figure out the largest perfect square that divides into 460. So we have x is equal to 30 plus or minus 2 times the square root of 115 all over 4. And now we notice each of the terms I am circling is divisible by 2. So this becomes 15 plus or minus the square root of 115 all over 2, which actually gives me 2 answers. 15 plus the square root of 115 over 2, and 15 minus the square root of 115 over 2. Now we're going to have to approximate those, so we're going to punch those into our calculator. We find out that this first one is approximately equal to 12.8, and we find by punching into the calculator that this second one is approximately equal to 2.1. 12.8 is way too big because if you'll recall, the original rectangle was only 10 centimeters by 20. Well, there's no way you could cut out squares that big. There's not enough of the original paper to do it. So this answer has to be rejected. 2.1 is a feasible answer. So your correct answer here is approximately 2.1 centimeters, and that represents the length of the side of the square that you would cut out from each of the corners. What makes this problem ugly is the fact that the quadratic that we came up with did not come out with nice integer answers or whole number answers. It came out with irrational answers, which meant that we had to approximate on our